What is up, guys? Today we're going to be going over some binary, understanding it, and then in the next tutorial we are going to be going over converting binary to ASCII, which is just text. So we've all seen binary code, and we just think of it as a bunch of ones and zeros in long strings like this bit here. But these ones and zeros can be represented as decimal numbers. So I'm going to show you how to read these numbers as decimal numbers that we're used to in our daily life, so like 10, 20, whatever. And then I'll show you how to use those numbers and your keypad to translate them into text, but that'll be in the next tutorial, so stay tuned for that. And just to make sure, just to know, your computer doesn't use the decimal system, it uses the binary system. I think that's just me trying to remember shit. So here's our first example. The first simple example of binary. 1 0 1 0 1. And let's think of that as empty slots. And yeah. So first off, you read binary from right to left, not left to right. So this is ASCII. What we write on our keyboard is all ASCII to whatever it is. And we read that from left to right, except from the Japanese who read it from right to left or whatever. But in binary, you read it from right to left, so you go that way, the way that I'm highlighting the text. That's just the way it was designed, not much you can do about that. The first slot here, this one here, it represents the decimal number 1. The second slot represents the number 2. The third is 4. The fourth is has a value of 8. The fifth value of 16, and it continues like that. So it's all multiples of 2, and this will never change. It'll just keep going and going and going and going. By putting a 1 or 0 in these slots, you're saying that you want a corresponding value that is attached to that slot, or you don't. So I'm just going to try and explain this. So the first slot, which I'm putting the number 1 over, which represents number 1. So that's 1, yeah? The next slot represents 2. There we go. Let's make that sit over that bit there. And the third slot represents number 3. No, it doesn't. No, ooh, ignore that. It represents number 4. Then the next one represents number 8, and then 16. So if I bring that all up so it's easy to look at. So that one goes to 16, yeah? And then this one means 8, but as it's 0, you ignore this 8. So it doesn't exist. And then this one here corresponds to the value 4, and this 0 here corresponds to the value of 2. But as it's 0 and not 1, it doesn't exist. So it's still there, but it doesn't exist. It's represented as just number 0. And then you've got 1, which just represents 1. Now to understand this, to understand binary, what you do is you just add them up. So 1 is represented by the value 1, so it's just, let's put that over here as 1. And then you add them up, so let's do a plus sign, if it lets me. Lagging out here, this isn't so good. Right, there we go. Where were we? So then we go to the next number 1, and that is represented by the number 4. So then we add on 4. And then we go another add on, and we add on 16. So when you add those together, you get 21. So equals 21, and that is what this binary number equals, 21. Let's move on to the next bit. So let's do some quick changes. Just pause the video and we'll see what you could do. So first time, just do these simple exercises and see what you can do. So pause the video now. Right, okay, so the first one, what we're going to do is we're going to go 0. That represents number 1, but it isn't there because it's 0. And that one represents number 2, and so does this one. But that one represents number 4, because it's 2 times 2, which equals 4. So that equals 4. And then the next one is the same, it equals 4, because this one is in the column number 4. And there's no other ones that you can see. And it doesn't matter how many zeros you put after this, it still equals 4, so I could keep on adding zeros and zeros and zeros, but it still equals 4. The next one, we're going to go 1, 2, 4, 8, 16, and it equals 32. And the next one, we're going to go, that equals 1, and that equals 2. So this one equals 2. Oops, kind of deleted that. That equals 2. Let's just check up on the answers. 4, yep. 4, yep. 32, yes. And 2, yes. So that's it for today, guys. Just if you didn't understand this, just post a comment under the video, and I'll try and get back to you and help you out as much as I can. So that's it. I'll see you around, and stay tuned for the next video in which we will be converting binary into ASCII 2, which is just text. So don't forget to subscribe, rate, and I'll see you around.